I'm Casey Day. I am a teacher in Frederick County here in Maryland. I teach CTE courses and computer science, and this is a unit that I developed over during distance learning in the springtime for my students to fit in a couple of different ways. To allow for all my contact information is here. So if you have any questions later, or you need something else, or something doesn't work, just let me know, and I'd be happy to look at it and help you try to figure it out, or figure out where the error may lie. So robotics is something that this was kind of shared with us by our curriculum specialist, that this was now available, and then I just kind of took it and had some fun with it. Because it's very engaging for kids. We know kids love robots. They love the opportunity to see and to do the things. I know the kids always love the robotics units we teach when we're teaching in school. But it also gave them a really authentic and tangible way to see what their programming was doing. A lot of times as we're programming with kids, they don't get a chance. We know what it's doing. We can see it in the program, but a lot of times the changes are very small, or the actions are very small, and they don't always see how that translates out. Whether you're working with conditionals, or you're working with loops, or you're working with anything really, counters, it's an opportunity for you to be able to see all of that. So additionally, it really hits a lot of standards. When I look at here we go. When I looked at the standards that we were able to hit, I just kind of summarized them into a document so that you'd have them if you needed them. But it not only hits our computer science standards in the state of Maryland, but it also hits a lot of our tech ed standards, our STEM standards. It reaches over into lots of different categories. So it pulls together all those understandings of algorithms, all those understandings of problem solving, working on perseverance, because robots never do what you want them to do the first time, or usually the second time, and getting kids to really kind of understand that perseverance piece as they're working through. So I've just listed there what I saw them as connecting in, so that it would give you a little bit of a background with that. And so, like I said, just the problem solving aspect. So the challenge really was in the springtime that we couldn't put robots in the hands of kids. I couldn't send them home. That was for sure. They do enough damage in the classroom, but I couldn't send them home. So I tried to find a way to do this alternatively. So Vex is a robotics company that has lots of different physical robots that do lots of different things, and they do competitions, and they do lots of activities. They developed, and it came out shortly before the pandemic hit, this virtual robotics. And this is the robot that it's actually based on. This is the prototype that when you see it on the screen, this is what it looks like. And it's good for kids to get a sense of where things are, because they don't really understand, what does it mean, the sensors? What do you mean, the pen? I don't understand, what you're talking about. So it's a basic, simple robot with a magnet here that turns on and off. It has a pen that changes color, goes up and down. It has a down eye sensor here, so you can see underneath of it and pick up the colors or things from underneath. It also has a front eye sensor here, so that it can see ahead of it for things that are standing up. It has some bumpers, right and left bumper sensors, as well as a gyroscope and some location sensing tools. So it's a pretty basic robotic structure, but it provides a lot of different opportunities for kids to be able to solve problems and do different kinds of challenges. So this is the robot that everything is going to be based on. So the question is then, what is Vex? So I'm going to take you in and show you the program really quickly, and then I'm going to give you a chance to try it out. Without a whole lot of instruction, I'm going to let you just play with it a little bit, but that didn't work. So let's go back out here, and we'll open it up here. Here we go. Okay, so this is Vex Robotics. It is it's available as a text-based language in Python. It's all underwritten in Python, or block-based language. And it's a nice tool, and I'll show you a little later. It's a nice tool for students who are making that transition from block-based programming into text-based programming, because they can watch their code appear as a block program. But the program works very simply, basic block structure program. I can move my robot forward. I can change the distance that I want to move him. Everything typically relates in millimeters in this particular setting. I can turn my robots different directions. I can, you know, have it drive backwards or forwards. It has lots of simple basic drop downs, which make it a little easier for kids than sometimes having a ton of code. They can just make some simple drop down changes. In addition to having the drivetrain type of basic motions for kids, it has access for the magnets. So it has access here for the magnet to boost or to drop, anything that needs to do, what's up. It has some look types of things which have a lot to do with the pen and the pen color, lifting the pen up, putting the pen down. It has, as you get more advanced, you get into loops and some of those control mechanisms, counters, and then you get into the sensors, looking at bumpers and distance sensing and looking at you know, visual sensing of objects and colors. You can go through your basic operations, work through with variables, and then you can customize your own blocks. You can write a piece of code and create it as a block and drop it right in there. It also has a great commenting feature so that you can have students leave that information as you work with students to, you know, to code well and to use, you know, good templating. But this is all nice and lovely, and we have kids do this all the time with different kinds of things. But the fun of Vex really comes here. There's a button up here called the playground. And when I click the playground, it opens up a second window, which sits on top, and it provides the arena, basically, for the robot. So there's lots of options. There's a grid. You know, there are ones that have mazes and discs for robots to go through. They have to pick up the metal discs and bring them back with their magnet. My computer is evidently very slow today, but it has opportunities to go through mazes and get around these. These are objects that the robot would have to send. It has a castle crasher type of a setting with them off the edge as they go. My internet is unstable. That's not good. So just let me know if you can't hear me or something goes weird. We're getting a storm. Castle crashers for kids to go through. But basically what happens is once you get the playground up, just going to put the basic playground up, then students can watch what happens when their little robot, who's down here in the corner, runs this code. They're able to kind of watch as it goes, you know, not the most exciting code. I probably shouldn't have put reverse in there because he's going to turn right and then he's just going to back up into the wall. So I can then change my direction and rerun my code to be able to see what happens. I can also play my code step by step, which is something that I really worked with my students on last year to get them to understand that they need to troubleshoot from the top to the bottom or to work systematically through a problem. So they have an opportunity where you can have students work on this step by step by clicking the step here, and it will step them through the first one, you know, so step there to the second code, and it'll wait for me, and I can see, did that do what I wanted? And especially in robotics and gauging distances, it gives them an opportunity to really think through those individual pieces, and then I can see it turn, and then I can see it, you know, take out my next code that's there. So what I did with the information after, well, honestly, we heard about it in a meeting, and then I just spent like a day or two just playing with it because honestly, I was really bored. It was, you know, quarantine time. I didn't have anything else to do. So I just played with these virtual robots for a good while and just, you know, really enjoyed them and started playing with them during the meeting, I think. And then I had to force myself to pay attention because it was that. So I'm going to be really brave, and I'm going to go ahead and show you, let you go out and play with the robots. So what I did is then take some challenges that are there, and I'll show you those and create some challenges or modify some challenges that they provide for kids. So here's what I'm going to have you do. There is a, this is one of the basic challenges that's in Vex. And so I'm going to have you go to the website, check it out, play with it a little bit, and see if you can solve level 1 or level 2 of this challenge. Okay, the important thing to remember here is that each square on your grid, it represents 200 millimeters. So that's just an important little piece as you go through. But this is a pretty basic challenge that I work with students as they work on the very beginnings of being able to drive and turn. So go ahead. I was going to divide you into groups, but I think we can all work together in one big group. So if you want to go ahead and visit vr.vex.com, give it a try. Talk amongst yourselves. It's Friday quiet day, evidently. Friday quiet day. Talk amongst yourselves to be able to think about, what do you think your students are going to think? What do you think will be intuitive for them? What do you think is going to be tricky or challenging? All right, so this was the case because one of my students continued to put very similar, I'm like, this code doesn't even begin to answer this question. It didn't line up any of the, it was like a drawing challenge, and they put in like a driving code, and I'm like, no. So I started requiring them to give me the full screenshot with no, no cropping, no little small areas of screenshots. I want the whole screen. I want to see your name on it. And so let's see the date and the time. And so that slowed that down a little bit, but they got me on a couple of them, but then I got them back. So it's all good. So we're even, but they're sneaky. Sneaky. All right, so some of the other resources that VEX has are, and I'll take you in to show you ways to save and load programs. So once they have their basic programs, they can save them. They do have to continue to use them on the same computer because the way it drops the information in. It also provides it in a lot of languages. If you're working with students whose primary language is not English, it provides some additional scaffolding and support if you're working on the computing concepts that students could, be looking at in whatever language they happen to have as their primary language. There's also some examples that are on there. So when I look at the VEX page, up here at the top in this files box, just move you out of the way. A lot of things happen from here. This is how I can load from my device or save to my device. And there's resources in the unit for kids that show them how to do this. I can load a new text project, which is where it will pull in the information in Python so students can work, if you have more advanced students or that's what you're working on, there's opportunities to do that. If I'm working in block-based, I'll just throw a few things in here. If I'm working in the block-based programming and I'm trying to make a connection for kids to the text-based programming, I can simply click this little button up here to show the code, and it will pop up a viewer to let me see the code that was written to do the blocks that were there. So kids can watch as they drop a new block in, they can see the code be written as they go. And they're like, oh, there it is, look at this, it didn't land. So there it is, drops in the next piece of code in the way that it's written. There are also tutorials that are available here for students, and a lot of them are embedded in the unit. So if students or teachers or any of us click on the tutorials, it has some of the basics that'll walk you through and show you how to do things from as simple as moving them and taking blocks away to doing things like using loops or how to manage driving forwards, how to save your documents. So there's some really good tutorials. When we started in distance learning, they had like 3, and then they added a tremendous amount to the resources that were here. There are also activities, which I'll show you a little bit more later, which is kind of what you were working on before, in that there are a lot of different challenges and activities that they provide to be able to use with students, sort of customized. They provide them in Google Docs so that it's easy for you to make a copy and then customize it for your students, which is a great way. I took some of them during distance learning for some of my students who struggle more, and I significantly simplified them and then was able to share those in Schoology on a much simpler basis with that group of students versus some of my other students that I knew could handle a lot more challenge at that time. So that was a nice option, because usually those things end up in PDFs that you have to go through some hoops to get modified. So there are also a few other tools that are here for you. There is a question button, and this will, if you click on any box, for example, if I click this box here to set the robot pen color, it's going to go through and explain that box for me. It's going to explain what it does, how to use it, and then give students an example of it. And that would work for any of the boxes that you use. It gives you what it is, how to use it, and here's an example. And then talks them through the code, which is a really nice tool for us or for them if we're not sure how something's going to work. There are also examples that are in here in the file button. So you can load up an example and it will show you, it will have it already written for you. So for example, if I wanted to see the robot draw, I can click in here and it'll bring up a simple robot drawing code that's written. They do a really nice job in leaving comments and explanations as they go through, but I can just simply load this code and it will run it for me to show. So it highlights the blocks as they run the code, so it shows what they're doing, and that's the entire code. It's not a very exciting code, but there are also, and it's another tool that's here if you have students who are working on more advanced skills, you know, like counters and variables, things like that. This is a variable program that each time they repeat the code, it increases by 1, kind of a counter. And there's a button up here, looks like a, what are those things called, protractor, that will keep track of my variable information. It'll show me what my variable is. My variable is times repeated. That's what we defined up here, where we set it to, and then it'll keep track of its value so that kids can either run it step by step or they can run the whole program and really see the value of that variable changing more tangibly than they can if they just have to abstractly imagine how that's working. So as this runs, you'll see that the times repeated up here will increase, and it will keep running through that program over and over, and it draws a little, I don't know, they didn't finish the shape. It kind of bugged me. Like I needed to go back and change the variables to make it work a little longer, but it's just the basic opportunity to see we're on the 5th run through, are we on the 6th run through, how are we going through, and how many more times does it go? All right, so I'm going to stop that there. And you guys are excited to see what was going to happen, but it just makes about 2/3 of that shape, and then it stops instead of finishing it up. So that was a little anticlimactic. All right, so let me show you a little bit more. I showed you those things. Oh, that was the other piece. Sharing this. The other way you can have students share information with you if you want to be able to look at and give them feedback on their code is there is a share button up here at the top. If you click that share button, it will save it as a PDF document that you can open theoretically, if you weren't having a thunderstorm, you can open up and see the student's code. Now you can't differentiate which student it was. They all could share this document together, so that's why I had them do screenshots so that I could keep a little closer eye on who was doing what. But it is a nice way. If you want to write a code and then embed it in something for the students to use, you can simply write your code, save it as a PDF, you know, transfer it over to a, you know, an image file, and then simply import it into whatever document you're working on. That is what we've done. All right, so let's take a look at the actual units that we're going to be working with. In the folder that is labeled, it is the one that just says Virtual Robotics with VexVR. It's this particular document. So we're going to take a look at how this lays out for students, kind of how this unit was laid out, what are the tools and resources that are there for you, how does it work for, you know, for kids, and then just stop me anytime if you have a question or you want to know, you know, want to know anything, just let me know and I will stop. So this unit is broken up into 5 basic sections. Just learning about the robot, some basic programming, some more advanced programming, some challenges, and then some real world application and what might a robot be utilized for. So the initial pieces work through very, very basic tutorials, getting started, using the playground. It shows them how to change camera angles. It shows them how to just open the playground and where to put it. And then students go through things like learning how to use help tools and naming and saving a project. They're straight up most basic types of things kids can do. And then they have exploration time. You know, can they find the playground? Could they name and save a project? Giving them just some time to explore. And that's really what I had them work on the first day, you know, in distance learning. We had a very short period of time that we could allow students to work in the spring. So we will be changing the days around a little bit. And some of this now, our county is doing a combination of synchronous instruction and asynchronous, you know, still all virtual. So some of this can be modeled directly with students. It can be, you know, discussed and practiced while we're together, and then they can work on some of the challenges more independently, to kind of go back and forth with that. And it gives them some opportunities to ask questions, which will be, I think, really nice. The next section works on some really basic programming skills. So it works on driving and turning, you know, your basic types of things. And 2 quick videos, again, they're from Vex. And then a couple of challenges for them to do. The first one is the distance drive challenge, and it's basically helping them really work through the concept of the fact that a grid is 200 millimeters and really looking at how do I make something drive. All of the challenges are actually linked right here, and I learned a really important lesson. Like, I tried to keep all the colors within my theme, and so I made these green links, and then I had numbers of kids just messaging me saying, I can't find the links, there's no work to do. And I'm like, oh, but this was the link right here, just click on it. So I changed them all back to blue so they'd all know that they were links. But the challenges come up as, like I said, as Google Docs, and they are, you know, going to do that. This is just having kids, can you move it 3 squares? How many millimeters is that going to be? They're really basic. And how to use the drop-down menus. So all of the challenges are linked in with, for kids, right in the unit that's provided. And I went through and put all of the how to take a screenshot on a Chromebook. That's our primary tool in Frederick County on every screen so that they wouldn't not know how to do that. Then it's the basketball drills, which you worked through when you were playing with the robotics unit. So again, the challenge is linked here. There's multiple levels, and I always tell them which level that I want them to paste. You know, I want them to try both levels and then paste level 2 on, or, you know, paste different pieces. And then the third challenge is you can complete 2 of them. You can complete level 1 and 2 or 1 and 3, and then just take a screenshot. This one has students using a number grid to drive the robot to their age and then to their birthday. So they have to operate on this number grid to figure out if each space is 200. What are the steps that we're going to have to go through to get to your birthday? Now, kids have it a lot easier because their birthdays, most of our middle schoolers, are here on the 2nd row. So there's not a huge distance for them to go. As we get older, it gets a little farther away and a little harder to get to. But they also needed to go back in then and either drive to your age at age 30 in the year 2035, so in 15 more years, or use a pen to mark your birth date, the month, the year, and the date. So kids enjoyed this one. This was a lot of fun. This was the first time they really had to persevere. They had to work through a lot of step-by-step because they were finding that their distances were off and they were getting a little bit lost. So that's kind of how that worked there. Then I worked with students a bit on some more advanced programming skills. I utilized this both in my computer science course and in my Invention and Innovation 7th grade tech ed course, exploratory course. And these skills I used more with my computer science kids and because the introductory piece, the kids just didn't have enough background at that point to really work on some other things. So this had them work first with the magnet and understand how the magnet would operate, how to lift and move different types of things. And then they had to go through this challenge where they had to move all of the blue blocks into the blue box, or they had to put one dot of each color into each box. They're just different ways to take and have them practice their driving and moving and using that magnet piece. So that's this one here for them to work on. Again, links up here. And then they had to do a little work with loops. and looking at how that works. So there's a tutorial that kind of works through the loops with them, and then they have to go through, they need to, it's another grid, another number grid, where they have to cross out every number. So they have to make their drawings go, left and up and, right and up and left and up, and then realize where the loop actually starts, because a lot of kids would start their loop here without realizing they have to get it up to the next level and turn to the right. So it took a lot of work for them to try to figure out how this would operate, what the algorithm was actually going to be. But for a lot of the kids, this was a nice challenge. It was a nice level challenge for them. So they had to go through there. Then they had to go through and mark them off in numerical order. So they have to come back to the beginning and mark each line and row. And then the big challenge for the kids who needed an extra, like I didn't require students to get to level 3, but for those kids that really needed the extra kick, the extra, acceleration, they had to go through and mark off each number in alternating colors. So odd numbers were red, even numbers were blue. So they had to constantly switch that pen back and forth and work out, kind of a loop within a loop concept. So again, most of my kids, we weren't there, but some of my cat friends. I took off level 1 for some kids, I took off level 3 for some kids, and just sent them. You can differentiate that pretty easily there. So then after kids had this is about as far as I went with my middle schoolers in programming. If in this year I could see utilizing some of the variable work with my computer science kids. We just hadn't gotten there, and my computer science class was a unique bunch. So we were struggling to get through some basics from home. So after this, it really comes down to some choice for students and giving them the opportunity to pick the things that they'd like to be able to do. So their goal, of course, here is just to get 3 in a row. They have to start with the Storm the Castle activity, which is where they're knocking blocks off of the, using their robot to knock all the blocks and clear the castle. And then they could choose 2 additional ones. I did mark several of them. This disc color maze and this grid map spiral are more challenging. Most of these involve, as you have an option, there's usually one that involves more movement skills and one that involves more of the artistic or other option type skills, so that in each category, no matter which way they went for tic-tac-toe, they were able to get some of that in both. But all of these link to to the documents that they need to be able to access them. Now, there were occasions in the spring when some of the other teachers in Frederick County that I shared this with were having trouble with these documents opening for some reason. And we went through and we troubleshot that forever. So finally I just deleted everything and I redid it, and I think that they all work now. If they don't, in the file that is hosted here, MCCE's file, there is a PDF as a folder of all the PDFs of all the challenges. So sometimes for students, we're sending kids PDFs. So I did just save all the PDFs in here so that you have them all if for some reason there's a glitch. I think we're glitch free now, but it was one of those really weird attachment link things that we couldn't figure out. So there are opportunities for kids to paste their screenshots from Storm the Castle and whichever 2 that they chose to do into this was like a nice central repository to put everything. It was easy to scroll through and find all the kids' work. And then the last piece of this that I added in actually at the end of the spring was the set of real world challenges. And these involve kids solving some sort of a problem. For the example, this one has students deciding and coming up with fencing options for a farmer. If you imagine that fences happened in millimeters, no kid ever questioned it, but being able to figure out a perimeter and look at what would be some options for the farmer. They have to draw 3 different, he has exactly 3,600 millimeters of fencing. They have to draw 3 different options for a pen for the chickens in 3 different colors and to be able to share with him. So that's, kind of one of those real world applications for students. Additionally, we have like a robotic vacuum cleaner challenge, which allows them to work like a Roomba and try to figure out an algorithm that would allow them to clean the whole floor and make sure the whole floor gets cleaned. So they have to work with random blocks to be able to kind of randomize angles and that they're going to be traveling. So they have them trace the pattern with their pen, see whether or not they're able to cover most of the areas in the home. So they were hired by Vroom Vacuum as a programmer. This is their challenge, to be able to solve that, to get the robot to work across all of those things. And the final one has to do with snowplows and working with this particular Castle Crasher playground is dynamic, and the fact that it will generate a different layout of spots every time you open it. So they needed to work out an algorithm that would work regardless of where the spots were. So they had to use a lot of sensors to be able to figure out how this is going to work. And the goal is to be able to move all the snow off the playground so the kids could go outside, you know, after a snowfall. And so they, you know, that they go past the red line, they get stuck in a snowdrift. So make sure all the snow gets pushed past the red line, but they can't actually go past the red lines. So, you know, they have to use their distance sensors. They have to use some of those, and it had to be random in the fence sense, that it had to be able to accommodate the changing platform that was there for them to work with. So that's basically the unit in a nutshell of what we kind of put together. There are other resources that are available that I linked in here for you that will help you as a teacher. There is a VexVR robotics knowledge base, which is a place to go and get information. So it's got how to get started, what are some of the features, here's how the blocks work, here's how the Python work, here's some additional educator resources, different ways to kind of help you out. There's also a teacher portal, and at that teacher portal, you have to log in, but then there are lesson plans, and there's some other additional resources that are available. Robotics, they do have a pacing guide and some standards alignment, looking at national standards and how all that pulls together. They even have an email that you can send home to families to kind of explain how the program works and what kids are going to be getting out of it. So like parents don't think they're just like playing Minecraft or Roblox or something like that. They have a blog where they post new information or things that they're trying out. And then I also included this link, which is just a fun activity, which goes along with the snowplow type of activity, but it's basically an autonomous vehicle, a robot autonomous vehicle. So there are just different options and things to kind of explore the same types of skills, but trying to get your autonomous vehicle around town to get people and things where they need to go. So yeah, I think this comes out of UC Davis or UC Berkeley or one of those. And this is just another little unit I did with applications of computer science during COVID, and it's just there in case you wanted it because I had it and if it was helpful.